Assalamu alaikum warahmatullahi wabarakatuh. We're going to continue with chapter 12, statistics part. What is the meaning of statistics? Statistics mean that you are collecting some data, organizing them in tables, then you present them in graphs, bars, charts, whatever the method that you want to present them. That make it quick, easy to understand the meaning of these data. So I have to study whatever I have to collect data from it, right? So what are the different type of studies here? You have a survey study, like you're going for your classroom and ask them about the favorite flavor for the ice cream, and you make it on the whole population. Or observational study, like watching birds in nature. You don't interfere, just observe without interfering from you and record. Or, for example, how many students wear glasses in your class? You just watch and record. That's it. And you have the experimental study. This is when you test something. You split people in groups, give one group a treatment, and compare the results. Like testing if a new vitamins or new medicine helps people focus better, or maybe you are treating a cancer, something like this. So the experiments are the only types that can show the cause and effect. Now you have collected your data, you organize them, but you need to know what are the features of these data. So we have something called the measures of the central tendency. These are ways to describe the center of the data, where your data are centered. The first one is the mean. Let me give you another example to understand what I'm doing here. Let me put 2, 5, and 6, and 4. Okay. The mean, to add all of the value and divide by how many value you have. Okay, so let me apply the rule. Mean equal, add them. So 2 plus 5 plus 6 plus 4. How many values you have? 4 values. So 23, 17 over 4. Okay, now the mean work best when there are no outlier. What is the meaning of outlier? Outlier is extreme value. For example, if I added for these values 75. Now 75 is very far from 2 and 5 and 6 and 4. So we call this outlier. Okay, now what about the median? The median is the middle number when values are ordered. So this means that wherever the value I give it to you, you have to order that. Maybe it's ascending order or descending order, it doesn't matter. So let me give you another example here. I have 2, 3, 4, 5, and 6. Okay, now are these odd number of values? Yes, we have 5 values. So I will just take the middle one. So the median here would be the middle one. What if I have even number of values? For example, 2, 3, 4, and 5. So I will take the average of their middle. So where's the middle here? What is the average? Add and divide by 2. So the median here would be 3 plus 4 over 2. So 7 over 4, which means 7 over 2, which means 3.5. This is the median. Okay, what about the mode? The mode is the most frequent number, the most repeated number. And it's very useful for categorical data when one value is repeated. Now, the median also is very important where there are outlier or data is skewed, which means that your data is shifted to one direction. Maybe it's increasing to this direction or decreasing in some direction. So mean, it works best when there is no outliers. The median work best when there are outliers or data is skewed, and the mode is useful for the categorical data when one value is repeated. Now, you have collected your data and you examine it, and you need to know where is the error. So we calculated using the margin of error. This tells how much the survey result might be off from the real population value. So it's equal to 1 over root n, and n is a sample size. Maybe your sample size is 100%, 1,000, 2,000, doesn't matter. But the bigger sample means that you are more accurate and there's a small margin error. And of course, it had to be positive or negative here, positive or negative 1 over root n. We already learned how to measure the center of the data and how the data are centered around the value, right? Now, going for the measure of spread, this means I'm gonna tell you how the data are far from each other or are they close to each other. We have three ways to do this. The first one is the range, the variance, and the standard deviation. The range tells you how far apart the numbers are, and the standard deviation tells you how much is the number spreading around the mean, which means they are close to each other or they are widely spreading out. So if you are having a small range, this means that you have a small standard deviation. And for the variance is just like the squared of the standard deviation. Now, the range is just like the maximum value minus the minimum value. For example, if you have something like this, 35, 19, 11, 10, and 20. What is the greatest value here? It's 35. And what is the smallest value? Is 10. So the range would be equal 35 minus 10 give you 25. And for the rules for the standard deviation here, if you are applying it on populations, this is the formula, the x, which means this is the value, and the mu, the mean, over n, the number of samples or number of population or number of values. Again, the variance is just the standard deviation power 2. So again, the measure of spread, range, variance, and standard deviation. The range tells you how far apart the numbers are, and the standard deviation tells you if the numbers are close to each other or they are widely spreading out. And for the range, maximum minus minimum. Go for probability distribution and expected value. What is the meaning of expected value? You have a process that is repeated many times, and you want to know the average outcome. We call this the expected value. So the expected value here equal to the value time its probability. And we're gonna take the sum. For example, if you have an X process, for example, it's equal 1 and 2 and 3. And for number 1, the probability of happening it is 0.2, and here 0.5, and here 0. Maybe 6. So how could I calculate it? I will multiply each value by its probability, and we add 2 times 0.5 plus 3 times 0.6. This is the expected value. So you multiply each value by its probability and add them all up. Now, for the normal distribution, I need you to imagine that you are measuring the height of your classmates, and you found that most of them are 160 centimeter. Some of them shorter than this, and some of them higher. They have heights more than 160, maybe 170, 190, 180, and so on. So if you draw a curve to represent this, you're gonna give you something like this. We call this the normal distribution curve or the bell shape curve. Now, as you see here, both sides of the curve are mirror image for each other. The left and right side balance perfectly. And also, you see that most of the values are near the center here. Here's the center. At the center, the mean equal to the median equal to the mode. And the area under the curve here equal 100%, which means it's 1 equal to 1. So as you see here, the percentage or the probability of getting the number here is 34%, then 13.5, then 2%, and then 0.5. But how you got this? Now, when you are deviated from the center or from the mean value, for example, the 160 here, centimeter, so this is one deviation or one standard deviation. These two standard deviation, these three standard deviation. It's the same here, but this is positive standard deviation, and here that you are going for a negative standard deviation. 1, 2, 3. But this is in the negative direction, which means that you are decreasing than the mean. Now, these values are very important and you have to memorize them. So 34, 13.5, 2%, and 0.5. Again, 34, 13.5, 2%, and 0.5. And again, the mean equal to the median equal to the mean. And all of them are in the middle. So if you know the mean and the standard deviation, you can predict how the data fall in certain ranges. The skewness show how your data is shaped or where the tail is it, or how you are disturbed from the normal distribution. Are your most of the data are shifted to the right or to the left? Is it positively shifted or negatively shifted? So this is the normal distribution as we agreed. In the middle, the mean and median, the mode are equal. Now, if you are positively skewed, this means that the right tail, as you see here, is long and your data is shifted to the positive direction. So this means that the mean is greater than the median. And for negatively skewed, the left tail is long. And this means that your data is directed to the negative direction. And this means that the median is greater than the mean, or the mean is smaller than the median. And most data will be on the right. So make sure that you understand the shape and to memorize the shape, because sometimes you have like SAT questions on it. So wherever he's asking you which measure best represents the center in skewed data, we choose the median, not the mean. This is a very important question. Wherever you are measuring the center of the data, you have to choose median. We use the binomial distribution while we're dealing with a yes or no, or success or fail, or true or false, or a fixed number of tries that you know it. So the same probability each time, like 50% for the head, 50% for the tail. So when you measuring the mean for such case, you have to use mu equal n times b. The n is the number of trials, and the b is the probability for the trial. The variance squared equal n times b times q. The n is the number of trial, and the b is the probability of success, and q is the probability of failure. And for the standard deviation, I'm just taking the square root for the variance. So again, n is the number of trials, p is the probability of success, and q is the probability of failure, and all the time it's 1 minus p. What type of study is the best for testing the effectiveness of a new medicine? Of course, it's the experimental study. Now, when outer layer are present in a data set, which measure is least affected and best represent the center? Of course, the median. It's work better when there are outliers or the data are skewed. Now, what is the median of the following value? Let me make sure first they are arranged in order: 45, 55, 60, 70, 85, and 90. How many values we have? 6, so it's even. So this means I have to take the average for the middle two. So 60 plus 70 over 2. This is 130 over 2, give me 65. Question 24. In a bowl of 5,000 people, 30% preferred coffee over tea. What is the margin of error? So it's here positive or negative 1 over root n. So positive or negative 1 over root 5,000. This is approximately for 70 times 70, which means that it's 4,900. So it's approximately 1 over 70, positive or negative. And this is approximately to 1 over 100. So I'm going to say it's positive or negative 0.01. Which of the following data sets has the smallest standard deviation? Smallest standard deviation mean smallest range, and you check for repetition. You have values that are repeated. And also if your set of data centered as a median. So let me check here. The greatest value here is 21 and the smallest is 19. So 21 minus 19 give me 2. This is the range. Here's 35 and 10. So 35 minus 10 give me 25. It's the same here, 35 and 10. So it's also 25. Here, 26 and 16. So it's 10. So the only choice here is A because you have a lot of repetition, as 20 is repeated 3 times, and also you have the smallest range 2. In a science exam for groups A and B, the results were in group A, the mean is 70 and the standard deviation was 3.2. And for group B, the mean was 70 and for the standard deviation 18.9. Which of the following best describes the correct statistical interpretations? Okay. What is the meaning of the mean? The mean means average score. So mean is the average score. Right? And what is the meaning of standard deviation? Standard deviation tells you how much your value are vary from the mean. Values vary from the mean. So if you have a smaller SD, this means that you are consistent or you are close to the mean, right? And if you have larger SD, this means that you are far or spread out from the mean. So smaller SD means that the results are around 70. But larger SD means that you are getting high scores or lower score than the 70. So which one has the highest and more consistent score? Group A. So let me take a look at the choices. Group A students are more consistent in their score. Yes. Group B students have closer abilities to each other. No. Group B scores show less variation. No, show greatest variation. So the strong and the strong also. Group A has the largest spread in the score. No, they are around the 70. So the only choice here is Group A students are more consistent in their scores. What is the expected value of the following probability distribution? Okay, expected value means that the value times its probability and we take the sum. So I'm gonna say it's 1 times 0.2 plus 2 times 0.5 plus 4 times 0.3. So here 0.2 plus 1 plus 1.2. So 1.2 plus 1.2 give me 2.4. Company offers a pizza in a draw. What is the probability that a randomly chosen winner get either a gift card or a speaker? Okay, so here the total is 15 plus 5 plus 10 plus 10, so this is 40. This is the total. And he's telling me that to either get a gift card or a speaker, so it's a 25 over 40. So it would be 5 over 8. So let me match the choices here. 0.25, of course, no, this is greater than the half. So this one neglected and this one is neglected. Also, it's greater than half. So this is 0.6. Two dice are rolled one after another. What is the probability that the first die chose a number greater than the second die? Okay, so okay, we have two dice. This means that the total outcome should be 6 times 6 equal to 36. The total is 6 times 6 equal to 36, right? Now, I need to see how many times I could get the chance that the first die show a number greater than the second die. So starting from 2, so 2 and 1, 3 and 2, and 3 and 1. 3, this is 4 and 3, 4 and 2, and 4 and 1, 5 and the 4, 5 and 3, 5 and 2, and 5 and 1. 6 and 5, 6 and 4, 6 and 3, and 6 and 2, and 6 and 1. So the total events, or sorry, the events here would be 1 plus 2 plus 3 plus 4 plus 5. So here it gives me 15. So now the probability is 15 over 36. So divided by 3 here, it would be 5, and divided by 3 give me 12. So it's 5 over 12. You randomly select 2 fruits from a basket containing 5 apples and 3 bananas. What is the probability that both are apples? So we have for the first pick, the probability of getting an apple would be 5 over the total, which is 8. And these are 2 independent events, so I'll just multiply the probability. So for the second pick, I already take one of the apples, so I left those 4. And of course, also the total will decrease by 1. So it's 7. Let's multiply. 5 times 4 is 20. And 7 times 8 is 56. So this one would be 5 over 14. And actually, you could simplify before doing this. This is 4, and this is 2. So 5 over 15. A random variable x takes value 1, 2, and 3 with probabilities 1 over 6, 1 over 2, and 1 over 3. What is the expected value? The expected value, the value times its probability. And we take the sum. So here's the sum. So it would be 1 over 6 times 1 plus 2 times half plus 3 times 1 over 3. So this would be 1 over 6 plus 1 plus 1. So 2 and 1 over 6, which means it's 2.2. What is the best description of a bell-shaped symmetrical graph centered around the mean? centered around the mean means it's normal distribution. The normal distribution with a mean of 50 and a standard deviation of 5, what is the approximate probability of selecting a value less than 55? Let me draw the curve for you to understand. This is not an accurate one, but I'm trying my best here. So he said that the mean is 50 with a standard deviation of 5. So this is 55. This is one standard deviation. This is two standard deviations. This is three standard deviation. This is 45, 40, and 35. Do you remember the percentage here? This is 34, 13.5, 2, and 0.5. The same as here. So he's telling you I need the probability of selecting a value less than 55. Here's the 55. So I need to add all of this part. So I know that from here to here, this is 50%. So I'm going to add 50% plus the 34% here. So it's 84%. In a normal distribution with a mean of 10 and a standard deviation of 2, what is the probability that the value is greater than 12? So here, this is the mean, 10, standard deviation of 2, so this is 12. The probability of getting a number greater than 12. So I need this part. So this would be 14. And this would be, so here, this is 34%. This is 13.5. And this is 2%. And this is 0.5. So I have to add all of this. So 16%. A data set is normally distributed with a mean of 12 and a standard deviation of 2. What is the value of the probability from 8 to 14? Here, in the middle, you have the mean, which is 12. And you have a standard deviation from standard deviation of 2. So this is 14, 16, 20, and this is 8. Sorry, this is 10, 8, 6. So I need from 8 to 14. Do you remember? This is 34%. This is 13.5. And this is 34 again. And this is 13.5. So I have to take from here to here. So 34 plus 34 plus 13.5. So here, and so it's 81.5%. If the probability of a machine working successfully is 80%, what is the probability that at least one of the machine work out of 3 tested? Okay, at least one work, so maybe one work, or maybe 2 works, or maybe the 3 works, right? So he told me that the probability of success is 80%, which means it's 0.8. So this means that the failure is 0.2. Now he needs the probability that at least one machine work out of the 3 tested. So the probability of one at least equal to 1 minus the probability of 3 fails. Okay, so here 1 minus 1 fail with 0.2. So 0.2 times 0.2 times 0.2. So it gives me 1 minus 0.008. So it's 0.992. In a binomial distribution of the probability of success is 0.6 and the number of trial is 10. What is the mean? So mean equal n times b. N is the number of trials and b is the probability of success. So 10 times 0.6, so it's 6. In a binomial experiment repeated 25 times, if the probability of success is 0.2, what is the standard deviation? Okay, now the standard deviation equals the square root of n times b times q. N, the number of trials, b is the probability of success, and q is the probability of failure. So 25 times 0.8, 0.2, and the failure is 0.8. So this means it's the square root of 25 times 0.16. So it would be 2. How you solve this? It's 25 times 16 over 100. So this is 4. 3 here. This is 1. And this is 4. 16 divided by 4 gives you the square root of 4, which is 2. In a binomial experiment, if the mean is 20 and the variance is 16, what is the probability of the success? Okay, now I need the probability of the success. Do you remember the rule of the variance? The variance here, NBQ, and the mean equal to NB. Okay, so I need to get the Q first to get the B. So I'm going to divide variance, Q equal variance over mu. So the variance here is 16 over 20. So if I simplify, it would be 4 over 5. And I know that the B equal 1 minus Q. So 1 minus 4 over 5 give me 1 over 5, which means it's 0.2.